Good morning, student. You are watching You Will Love Math for beautiful mathematics content and beautiful mathematics learning with proper problem solving. So today we will discuss about the remainder theorem, which is basically invented by Euclid. So you know Euclid as the father of geometry, but he also contributed in the field of algebra. It's a beautiful theorem and a fundamental theorem of algebra which is proved using the concept of division algorithm. So here px is a polynomial which is divided by x minus a. Then the remainder will be p of a. So if we put a in the value in terms of x, so if we put a in terms of x or instead of x, then we will get the value of the remainder for division by x minus a to the polynomial px. Understand very carefully. So it will use the concept of division algorithm. So you know the basic theorem or basic formula: dividend equals to divisor into quotient plus remainder. So you know that in the arithmetic also you also use that formula in the lower class. Okay, so dividend equals to divisor into quotient plus remainder. So if you divide 17 by 2, what will be there? 8 will be quotient and 1 will be remainder. So you have learned this in the lower class, in the very basic class of mathematics using arithmetic. Now we will use, or you will use the same thing to express px. So px equals to x minus a as a divisor into qx as a quotient plus rx as a remainder. So we will expressing here, or we are expressing here, px equals to x minus a into qx plus rx. So here one thing or one doubt is coming here: is rx is a polynomial of x, or r is a non-x value constant or a term? So the main complexity of the remainder theorem is coming here in the terms of Rx. So if Px is expressing as the polynomial of x and x minus a and qx are giving value of another polynomial, what will be? It is less than the Px. So what will be the remaining? Less than or greater than the Px, then what will be the value of Rx? So if Rx is a polynomial of x, no, Rx is not a polynomial of x. Since if Rx is a polynomial, then x can be taken common from Rx. So then the Rx will be changed. So x minus a into qx plus rx is a no, Rx is not a term of x. So it will be a constant value. So we can't express Rx in terms of x. Understand very carefully. I am repeating it again. Rx is not a term of x. So Rx is not a polynomial of x. Rx is a constant term, or Rx is a non-x value term. Okay, so Rx is not, or Rx is a constant term. So I am repeating it again and again. The main complexity of the problem is here. So x minus a into qx is giving a polynomial of x which is expressing in terms of px. So if rx is a polynomial, we can take common x from rx, which will violate the x minus a into qx. The term will change and the remainder will be also changed. So Rx is a non-x term, basically a non-variable term or a constant term. So now we are expressing or putting the value of a instead of x. So p of a equals to a minus a qa plus ra. If so, understand very carefully. We can write r of a, but there is no x. So where we will put a in terms of x for r? Understand? If r is a polynomial of x, then only we can put the value of a in terms of x. But there is no x, then where we can put x? So ra will not be there or rx will not be there. So then there is no a in rx. So where we will put the value of a in terms of x? Okay, so there is no x here, so there is no scope of putting value a in terms in rx. So ra will be basically a constant, so there is no scope of putting ra. So we will basically write it as r smaller or capital R. So express it as the we are stating, and the ambiguity, the doubt will be cleared here. So px will be px equals to x minus a into qx plus r, capital R or small r. Any value you can write, but no x will be there. No x will be there. Okay, so now the main final part is coming. Okay, so we are putting the value of x a in terms of x. So pa equals to a minus a into qa plus r. We have cleared the doubt because we have deleted the x from rx. Okay, so pa will be 0 into qa plus r. So the remainder has come here. So from the division algorithm, Euclid has proved a beautiful, marvelous fundamental theorem of division algorithm, which is called remainder theorem. So using division algorithm, the theorem of division, and which has invented by Euclid, which is called remainder theorem. So px is divided by x minus a, then the remainder will be p of a. Now we will solve a problem of remainder theorem for better understanding and for the better clarity of the theorem. The remainder theorem is tricky, little bit complex, and fundamental theorem of algebra. The whole number theory is depending on a part of remainder theorem. Okay, so the polynomial is here 3x cube plus x square plus 5x plus 3, which is divided by x plus 1. So which is divided by x plus 1, then what will be the remainder? So in terms of x plus x minus a, we can write here x minus of minus 1 for the plus 1. So x minus of minus 1. So a is here minus 1. So minus 1 will be substituted in the terms of, sorry, minus 1, we will substitute 1 in terms of x. Okay, so 3 into minus 1 whole cube plus minus 1 whole square plus 5 into minus 1 plus 3. So the value will be the remainder of that polynomial when it's divided by x plus 1. So 3 into minus 1 plus 1 minus 5 plus 3. Okay, so 3 into minus 1 minus 3 plus 1 minus 5 plus 3. Plus 3 and minus 3 will be cancelled out. So minus 4 will be answer as the remainder when the polynomial 3x cube plus x square plus 5x plus 3 is divided by x plus 1. So we have solved a problem of remainder theorem, and we have discussed the concept or the proof of remainder theorem also. So thanks for watching. It's a beautiful problem, beautiful theorem of algebra, and it is a fundamental property. It has a fundamental property in the field of algebra. So thanks for watching. You will love math. Keep watching, keep tracking. You will love math for beautiful mathematics and beautiful mathematics content.